Welcome back. Now we're going to work on quotient rule, but I have to say before we start that actually we don't need to use this rule at all because we have the product rule already. I think at some point one of the professors was so bored from students' questions like, "Sir, don't we have a rule for this? Don't we have a formula for this and stuff?" So he or she just came up with this quotient rule. Okay, let's see what it is, and let's see its relation with the product rule. So basically, if you have two functions, u and v, and if you define a function as their quotient, u divided by v, then you have the quotient rule to be, so it's going to be dy over dx, being v times du over dx minus u times dv over dx, so derivative of v here, and this is derivative of u here, right? Divided by v squared. Or if you'd like a short version without the dx's, you can write this as dy equals v du minus u dv over v squared. Now, let's remember the product rule. The product rule says dy equals u dv plus v du. Now, the first difference is that you have a minus sign, right? And the second difference is the order is different. You start with v du, and then you take away u dv. But the idea is the same. You just keep one of the functions the same and multiply it with the derivative of the other, and then here you change the order, and it is the same in here. You start with v and write du in product, and then you write u dv, right? So this way, product rule and quotient rule have similarities, so you may remember it easily once you have the product rule in your mind. Now I'm going to solve an example with the quotient rule, and then I'm going to solve the same example by using the product rule. Find the derivative of y equals x over 2x plus 5. Obviously, u is x, so you can write du to be 1, right? That's the derivative. And v is 2x plus 5, so dv is 2. Now, let's quickly write the derivative of y. So dy over dx. And if you remember the rule, which is v du minus u dv over v squared. So let's substitute here. v is 2x plus 5 times du is 1 minus, I write u, which is x, times dv, which is 2, over v squared. So it's 2x plus 5 squared. And if I just, manipulate it a little bit, that's going to be 2x plus 5 minus 2x over 2x plus 5 squared. And we end up with 5 over 2x plus 5 squared as our derivative. So this is how we use the quotient rule simply. Now let's try to do this with the product rule. So the product rule is that I'm going to write dy equals u dv plus v du. So I need to write u and v and their derivatives. Now for u, it's fine. U is x, du is 1. Now v is not 2x plus 5. Actually, I can write this function, let me write here, as y equals x times 1 over 2x plus 5, which means x times 2x plus 5 to the power of negative 1. So my v will be 2x plus 5 to the power of negative 1. So applying the chain rule, I'm going to have dv to be minus 1 times 2x plus 5 to the power of minus 2 times the derivative of the inside, which is 2. If I rearrange this, it's going to be minus 2 over 2x plus 5 squared. Now I know u, du, v and dv. I only have to substitute these into the product rule. Let's do that. So dy over dx will be, it's u dv, so it's going to be x times this. So x times minus 2 times 2x plus 5 squared plus v du. So v is, well, this is to the power of minus 1, so I'm going to write it as 1 over 2x plus 5 again, back to the fraction form, times du, which is times 1. Now let's play with this a little bit. This is going to be minus 2 times x, minus 2x over 2x plus 5 squared, plus 1 over 2x plus 5. So if you equate the denominators, you're going to get minus 2x plus 2x plus 5 over 2x plus 5 squared. And you can see that these simplify each other out. So 5 over 2x plus 5 squared, as we found by using the quotient rule. So at this point you can say, okay, I'm not learning quotient rule, I'm going to use product rule whenever I see anything like a fraction. And I'm going to do the conversions like this. Well, things may be tricky, okay? I'm warning you. I'm not suggesting you to not use quotient rule, because in more complicated expressions, you may need the rule, okay? But you can see that I find the same answer using the product rule, because the quotient rule is derived from the product rule anyway, okay? So this is totally your choice, but I'm going to explain and solve a few more examples by using the quotient rule anyway. So another example. So we have sine x over e to the power of 2x here. So obviously u will be sine x, du will be cosine x, and v is e to the power of 2x, dv will be 2 times e to the power of 2x. Now, the quotient rule says dy equals v du minus u dv over v squared. And again, for each question while solving questions, if you repeat this, it's going to stick to your mind, I believe. So let's do the substitution now. Dy over dx will be v du, so it's this one, e to the 2x times du cosine x, and then minus u sine x times dv, which is 2 times e to the 2x over v squared. So this is e to the 2x squared. Now let's play with this a little bit. I mean, this is cosine x times e to the 2x minus 2 sine x e to the 2x over e to the, well, power of power means multiplication. It's going to be 4x. And then, of course, I can take into e to the 2x parentheses. It's going to be cosine x minus 2 sine x over e to the 4x. Now you can simplify here and say this is cosine x minus 2 sine x over e to the 2x. So that's our derivative. So again, finding the derivative with respect to the quotient rule is no big deal. You have the derivative here, and the next steps are about manipulation. And that's pretty much it. That's how we apply the quotient rule, and it's now time for you to practice. Thanks for watching.